Hello, welcome back once again. Today we have a really cool integral. The integral from 0 to pi over 2, the sine of x squared divided by the sine of x plus the cosine of x dx. Let's call this integral I, right? So we're going to use the King's property. And what's that property? That the integral from a to b of f of x dx, that is equal to the integral from a to b of f of a plus b minus x dx. So this is a King's property, so we're going to use that. So our I is going to be the integral from 0 to pi by 2. So we're going to have the sine squared of pi by 2 minus x, right? Then divided by, so this is going to be the sine of pi by 2 minus x plus the cosine of pi by 2 minus x. And then we have our dx. So here we're going to have I will be equal to the integral from 0 to pi by 2. So up there we have that is going to be the cosine of x squared, right? Because the sine of pi over 2 minus x will give us the cosine of x. So this is going to be the cosine squared of x. Then divided by here, sine of that angle will give us the cosine of x plus the cosine of this angle will give us the sine of x. And then we have our dx. So now this integral right over here is also I, and we know from the original integral, our I, we know, is equal to the integral from 0 to pi by 2 of the sine squared of x divided by the sine of x plus the cosine of x dx. So what happens when we add the two i's together? It's going to make sense, right? So I plus I, we get 2i will be equal to the integral from 0 to pi by 2 of cosine squared of x, so plus the sine squared of x, then divided by the sine of x plus the cosine of x, and then we have our dx. So now take a look at the numerator. We have something really cool, and we know that the sine squared of x plus the cosine squared of x is 1. So we're going to have the integral from 0 to pi by 2. So this is going to be 1 all over. So we have here the sine of x plus the cosine of x, and then we have our dx. Cool. So what is next? We're going to use this nice identity. It is a trigonometric identity. We have that. So we have that the sine of x plus the cosine of x is equal to the square root of 2 multiplied by the cosine of x minus pi over 4. So we're going to use this nice identity here. So we're going to have 2i is equal to the integral from 0 to pi by 2. So this is going to be equal to 1 all over. So this will be square root of 2 times the cosine of x minus pi by 4, and then we have our dx. Okay. So divide both sides by 2 and take out the 1 over root 2. So we get I is equal to, this will be 1 over 2 root 2. Then the integral from 0 to pi over 2, 1 all over. So we have the cosine of x minus pi by 4, and then we have our dx. So let us make a substitution here, and you know what I mean. So we're going to let x minus pi by 4 equals y. Differentiate both sides, we get dx is equal to dy. So our I is going to be equal to 1 over 2 root 2 multiplied by the integral. So let's check the limit of integration. So when x is approaching 0, y is approaching 0 minus pi over 4, which is negative pi by 4, right? And when x is approaching pi over 2, y we approach pi over 2 minus pi by 4, which will give us pi by 4. And here we have 1 over the cosine of y, and here we have our dy. Remember that the cosine function is an even function. So we take note of the following: the integral from negative a to positive a of f of x dx. This is equal to the integral from 0 to a, right? of f of o, sorry, that would be twice. Yeah, cool. Okay, so of f of x dx. So this holds if f of x is even. Okay, so it must be an even function, and we know the cosine of y is an even function, so it will be twice, then 1 over 2 root 2, the integral running from 0 to pi by 4. Okay, of 1 over the cosine of y, and then we have y dy. So we know these two get cancelled with these two. So from here now, we have our I is equal to 1 over root 2, multiply the integral from 0 to pi by 4 of 1 over, let's multiply up and down by the cosine of y. So we get cosine of y divided by, so down here will be cosine squared of y, and then we have y dy. So I will be equal to 1 over root 2, the integral from 0 to pi by 4. So this is going to be cosine of y, then divided by cosine squared of y is 1 minus sine squared of y, and then we have our dy. So you can see that we have something really cool now and easy enough to solve. So we're going to let x equals the sine of y. Differentiate both sides, we get dx will be equal to the cosine of y dy. So our I will be equal to 1 over root 2, the integral. Now, when y is approaching 0, x is approaching cosine of 0, which is 0. When y is approaching pi by 4, x is approaching the sine of pi by 4, which is root 2 over 2. And here we have 1 all over 1 minus x squared, and we have our dx. So we know we have difference of two squares down there, which we can factorize. So we have 1 over root 2. So this is going to be integral from 0 to root 2 over 2. So we're going to have 1 over. So this is going to be 1 minus x multiplied by 1 plus x. And then we have y dx. So partial fraction decomposition, it is easy enough. So one can easily realize that we have 1 over root 2. Then we're going to have here. So what are we going to have? So if you write this as 1 over 1 plus x minus 1 over 1 minus x. So if you check here, we're going to have, no. We're going to have the negative first. So if you take this as this, then we're going to have up there 1 plus x minus, we're going to have 1 minus x, which obviously give us 2x, right? So it means there will be 1 over 2 outside, right? So there will be 1 over 2. Are we? No, we're going to add. Oh, so sorry for that. Oh, pardon my mistake. So we're going to add, right? So by adding, we have plus here. So x will vanish and we're left with only 2. So it means there will be 1 over 2 outside, right? So this is what we have right over here. And remember, we're integrating from 0 to root 2 over 2. And then we have our dx. So now, our I is going to be equal to, so here we have 1 over 2 root 2. The integral from 0 to root 2 by 2 of 1 over 1 minus x dx. Then plus, we have 1 over 2 root 2. The integral from 0 to root 2 by 2 of 1 over 1 plus x. And then we have our dx. Okay, so this is really cool from here, right? So now we have I is equal to 1 over 2 root 2 factored out, right? Then the integral of 1 over 1 minus x will give us negative natural log of 1 minus x. Okay, then from 0 to root 2 by 2. And here plus, this will be the natural log of 1 plus x from 0 to root 2 by 2. So now putting in the limits, so we get I is equal to 1 over 2 root 2 Sorry for that. So this is going to be when you put the root 2 by 2, we get negative natural log of 1 minus root 2 over 2, right? When you insert the limit 0, so we're going to have the natural log of 0, which is just what we have here. And then we have the natural log of 1 plus root 2 by 2 right over here. So when you put x equals 0, we get 0. So this is what we have from here. Now we're going to write this as I is equal to 1 over 2 root 2. So we're going to have the natural log of 1 plus root 2 by 2 minus the natural log of 1 minus root 2 by 2. So with this property of logarithm, the log of a divided by b, so let me write that nicely. So we have this property of logarithm. The log of a divided by b is equal to log of a minus log of b. So we're going to use that identity here. But before that, let us first simplify properly. So this 2 root 2, and we have the natural log. So this is going to be, so we're going to have 2 plus root 2, then divided by 2. And then minus the natural log of, so we're going to have 2 minus root 2 divided by 2. So our I is going to be equal to 1 over 2 root 2. So this is going to be natural log of 2 plus root 2, right? Minus natural log of 2. Then minus here, we're going to have 2 minus root 2. And then there will be a plus natural log of 2 right over here. Don't forget that. And we can see that this and this cancel. And here we use that property. So we get I is equal to 1 over 2 root 2. The natural log of, so we're going to have 2 plus root 2 divided by 2 minus root 2. So we're going to rationalize, right? So let's say how we're going to rationalize this. So we have 2 root 2 divided by 2 minus root 2. So we're going to multiply by the conjugate of the denominator, right? So 2 plus root 2. So up here, so what are we going to have? So 2 times 2 will give us 4 plus 2 root 2, right? Plus 2 root 2 and then plus 2. Then divided by difference of 2 squared. So that is going to give us 2 squared minus root 2 squared. So this is going to be equal to 6 plus 4 root 2. So that would be divided by 2, which will give us 3 plus 2 root 2. So finally, we have our solution. That I, which is equal to the integral from 0 to pi by 2 of the sine squared of x divided by the sine of x plus the cosine of x dx, that is equal to 1 over 2 root 2 times the natural log of 3 plus 2 root 2. Oh my god, this is really cool. If you really enjoyed this video, please kindly support the channel by subscribing. Also like, comment and share.